Hello everyone, welcome to Spec Talks. This is P. Aishwarya and my registration number is 22B01A4640.
This is Y Devi Sanjana and my register number is 22B01A4658. We did this PPT under the guidance of Dr. M. Prasad sir, PhD, Associate Professor in SWET Bhimavaram.
And today our topic is all about shared memory. So coming to our topic, shared memory, the first slide is all about what is shared memory. Coming to the definition, it tells us about shared memory is an operating system feature that allows the database server threads and the processes to share data by sharing access to pools of memory. And also, the database serves uses shared memory for the following process to reduce the memory usage and disk IO. And here we have a pictorial representation of process 1, process 2 and the shared memory. And coming to the slide, this is all about IPC through shared memory. And coming to the information, interprocessor communication through shared memory is a concept where two or more processes can access the common memory and the communication is done via the shared memory where changes made by one process can be viewed by the other process. And also, the problem with pipes, FIFO, and message queue is that for two processes to exchange information, the information has to go through the kernel. Server reads from the input file. The server writes this data in a message using either a pipe, FIFO, or a message queue. The client reads the data from the IPC process communication through shared memory is an NL. Again, requiring the data to be copied from the kernel's IPC buffer to the client's buffer. Finally, the data is copied from the client's buffer. In this slide, we can see a pictorial representation of a shared memory, in which we have components like process A, shared, process B, and the kernel. The process that happens between process A and shared is that process A writes into the shared memory, and the process that goes between shared and process B is that the process B reads from the shared memory. So this slide is all about request a memory segment that can be shared between the process to the operating system. Associate a part of the memory or the whole memory with the address space of a calling process. A shared memory segment is a portion of physical memory that is shared by multiple processes. In this region, processes can be set up structures and others may read or write on them. When a shared memory region is established in two or more processes, there is no guarantee that the regions will be placed at the same base address. Semaphores can be used when synchronization is required. This slide is all about why to choose IPC through shared memory. Coming to the first point, it tells us about usually interrelated process communication is performed using pipes or named pipes, and unrelated process communication can be performed using named pipes or through popular IPC techniques of shared memory and message queues. But the problem with the pipes, FIFO, and message queue is that the information exchange between the two processes goes to the kernel and it works as follows. The second point is all about that the server reads from the input file. The server writes this data in a message using pipe, FIFO, or message queue. The client reads the data from the IPC channel. Again, requiring the data to be copied from the kernel's IPC buffer to the client's buffer. Finally, the data is copied from the client's buffer. Functions of IPC using shared memory. Two functions shmget and shmut are used for IPC using shared memory. Shmget function is used to create the shared memory segment, while the shmut function is used to attach the shared segment with the process address space. The first function is the shmget function. The first parameter specifies the unique number called key identifying the shared segment. The second parameter is the size of shared segment. Example 1024 bytes or 2048 bytes. The third parameter specifies the permissions on the shared segment. On success, the SHGET function returns a valid identifier, while on failure, it returns -1. The syntax is that hash include sys slash ipc.h, hash include sys slash shm.h, int shm get key underscore t, key, size underscore t size, int shm flg. So here is the second function, the shmat function. The shmat function is used to attach the created shared memory segment associated with the shared memory identifier specified by shmid to the calling process address space. The first parameter here is the identifier which the SHM get function returns on success. The second parameter is that the address where to attach it to the calling process. A null value of the second parameter means that the system will automatically choose a suitable address. The third parameter is 0 if the second parameter is null, otherwise the value is specified by shm underscore rnd. The syntax of it is that hash include sys slash types dot h and hash include sys slash shm dot h. The void star shmad int shmid const void star shmad address comma int shmflg. How does interprocess communication using shared memory work? A process creates a shared memory segment using shm get. The original owner of a shared memory segment can assign ownership to another user with SHMCTL. It can also revoke the assignment. Other processes with proper permission can perform various control functions on the shared memory segment using. In this slide, we are going to learn all about SHMCTL function. Once created, a shared segment can be attached to a process address space using SHMAT. It can be detached using SHMDT. The attaching process must have the appropriate permissions for SHMAT. Once attached, the process can read or write to the segment. As the permission requested in the attach operation allows, a shared segment can be attached multiple times by the same process. Shared memory segment is described by a control structure with a unique ID that points to an area of physical memory. The identifier of the segment is called the SHMID. The structured definition for the shared memory segment controls structures and prototypes can be found in sys/shm.h. Thank you everyone.